In this video, I'm going to talk about one of the applications of set. Have you ever wondered how smartphones are able to capture the face of someone and not just capture the face of that person, they also tell you the boundary, they put a kind of square around the face of that person. If you check most modern phones, whenever you want to take picture, they tell you where the face of that person is. Have you ever wondered the magic behind it? The magic behind it is a concept known as machine learning. Most of those cameras and devices, they are powered by machine learning software. This software, they've been trained to be able to identify objects, and in this case they've been trained to be able to identify human faces, right? And that is what this concept is all about. This concept is all about training software to recognize objects or make smart decisions and so on. But I'm not going to go into machine learning. I'm going to go into a very interesting subset of machine learning known as object detection. But then I'm going to talk about one of the ways the computer scientists actually check for the effectiveness of their code after training for object detection. So let me explain what I mean. Whenever computer scientists or machine learning experts develop software that can recognize faces or tell the location of cars, they always want to make sure that the code is working correctly. And to check if your code is working correctly, you need a means to check how good your code is. And one of the ways computer science expert or machine learning expert test how good their machine learning code works is they use a concept known as intersection. Intersection over union. So the short form is IOU. So this is a concept that computer scientists or machine learning experts use to evaluate. They use this to evaluate the effectiveness of an object detection code, right? Of an object detection code. Now, I'm not going to talk a lot, I'm not going to go into object detection, but I just want to talk about how this IOU works and how is it connected to sets or how is it connected to set theory. But before I talk more about this IOU, let's take a look at a real world implementation of object detection. This is a software that somebody built to detect cars, faces, and so many objects, right? And you will see those squares around each of those objects. So I just want to show you a real software that was trained using intersection over union in being able to figure out objects in a picture or in a video. So let's take a look. So this is the software in action. You can see that from the software, from the video here, the software is automatically telling us which section of the picture is a human or where a car is, where we've got a person or traffic light and so on. You can see that the software is telling us exactly where each object are and what type of object they are. This software is used by virtually all advanced camera. This kind of software is used by almost all advanced camera to figure out where faces are, where human beings are, where cars are, and other objects, right? So the question now is, how does it correctly figure out the location of an object or a car and all of that? And when the person that built this, how is that person able to evaluate how good his or her code is? So I'm going to talk about a real world concept used by this person, right, to evaluate the functionality of this code that we are watching right now. So let's take a look at the concept known as intersection over union. Intersection over union is a concept used by AI experts to tell how good their prediction of an object is. So let's take a look at this scenario. So imagine this is an apple, right? So let me just have this kind of apple. And let's say you want to build a code that will be able to tell the location of an apple, right? Will be able to tell the location of an apple within an image or within a video. Now, we call this kind of rectangle bounding box. That is what AI expert call this bounding box. Now, this is the real or the correct bounding box. But then, whenever an AI expert is training or building his code to identify this object, sometimes their code may not be that accurate. Sometimes their code could predict that this is the location of the apple, right? So this is the correct bounding box. And this could be called the predicted bounding box. Predicted bounding box. Now the question is, how close is this predicted bounding box to the correct bounding box? To answer that question, AI experts use this concept of IOU. So now let's take these two bounding box and let's break it down. So let's say this is the predicted and this is the correct bounding box, right? So I'm going to use these two boxes. So let's say this is the correct box that we know to be the correct bounding box. But let's say the software is predicting this. How do we measure how good the software is, right? How do we measure that? Now, this IOU says you should look for the intersection of these two bounding boxes, which is the I. The I stands for the intersection, right? And the U stands for the union. Then this O, which is the over, is like divided by. So basically, what this formula says is you look for the intersection, you divide by the union, and whatever you get is the closeness. So you can say the closeness of the closeness, let me write it this way, the closeness or accuracy, you can call it closeness or accuracy of this predicted box is the intersection of the two boxes over the union of the two boxes. So now what is the intersection of the two boxes? The intersection of the two boxes is this region. So this region is the intersection of the two boxes. So what computer scientists or machine learning experts they do is they calculate the area of this intersection. They use programs, software to calculate the area, which is the intersection of these two, and that becomes the intersection. So let's say the area happens to be, so the accuracy now, so let's say the area happens to be, let's say the area here happens to be, let's say it's 10. And now, what is the union? The union is the shaded portion of both sides, right? The shaded portion of both rectangles. So let's say in this case, it turns out to be 24, or let's say 24, for instance. Now, this ratio is a measure of the accuracy. So this is what computer scientists, so let's divide, so this becomes 5 over 12. So this, if you convert this to fraction, to decimal, this is a measure of how accurate this predicted boss is. So this is exactly how computer scientists or machine learning experts that build object detection software, this is how they figure out the accuracy of their software. And they just use this simple idea of taking the intersection, which is like you taking the shaded area of a Venn diagram. So you can see this shaded region as like a kind of Venn diagram. And then they look for the area of both rectangles, which is the union, right? And they divide. And after taking this division, that gives them the accuracy of this prediction. So this is one of the interesting ways that computer scientists and machine learning experts use the idea in set theory to actually build real world software.